Hello HISD students, welcome to another week of Math at Home. Today is our fourth video and we are going to be dividing our lesson into three sections. We're gonna have our sixth graders are gonna be learning about algebraic expressions. Our seventh graders will focus on integer operations. And then our eighth graders are going to be learning about simplifying expressions. So let's get started. The objective for our sixth graders is going to be to learn to generate and compare two expressions to know if they are equivalent. And they're going to be doing this by using operations and algebraic properties, such as the commutative, the associative, and the distributive property. Today we are going to start with the commutative property. So let's look at this expression. We have 2 plus 4. And we have the next expression, which is 4 plus 2. The question is, are these two expressions equivalent? And equivalent just means, are they the same? So let's explore this with algebra tiles. Let's say that I have 2 units and then I add 4 more units. Well, if I put them together, that means that I'm gonna have a total of 6. Now, will this change if I change the order of operations? Well, if I have 4 units first and then I add 2, then that means that the total is going to be the same. So this is what the commutative property is all about. The order of operations does not affect the final result. But I know what you're thinking. Well, does that hold for any type of operation? Well, let's see. What if I have the expression 5 minus 4? And now I'm looking at the next one, which is 4 minus 5. Are these two expressions equivalent? Let's explore it with algebra tiles. If I have 5 positive units and I add 4 negative units, that means that I have, as a result, only one positive unit, or our result is going to be the number positive 1. What if I change the order of operations? If I have 4 positives and then I subtract 5 units, well, that means that I'm going to get a result of negative 1. So on the commutative property, it doesn't apply for subtraction. For the commutative property on multiplication, we are going to explore at these operations with fractions. We're going to have 1 over 2 times 2 over 3. And remember that when we multiply fractions, we are going to multiply numerators and then the denominators. So 1 times 2 over 2 times 3. This is going to be on top, is going to equal 2, and then it's going to equal 6. So my final result is going to be simplification 1/3. Let's go to the next one, and we change the order. And now we're going to explore 2/3 times 1 over 2. We're going to do the same, 2 times 1, multiplying numerators and then multiplying denominators. This is going to be equal to 2 over 6, which is going to give me the same result, 1/3. So I can say that the commutative property, or the order of operations, does work for multiplication. Same property, but now it's going to be for division. We're going to start with 4 divided by 2. And if I divide 4 into 2 groups, that's going to be equal to 2. Let's go to the next example. And on this one, we have 2 divided by 4. So we change the order of operations. But now this one actually is going to be equal to 0.5. So I can say that the commutative property, or the order of operations, does not apply for division. Our next algebraic property is going to be the associative. And what this is talking about is that the grouping of the operations in an expression does not have an effect on the final result. Let's see if on the following expression this is accurate. We're going to have inside of a parenthesis a 2 plus 3. And then outside of it, we are going to add 5. We know from last week that according to the order of operations, I have to work the parentheses first, and then I'm going to add the number 5. The next expression is the same numbers, but the parentheses are in a different position. So that means that the grouping is different. It's saying that the 2 is going to be outside, and then the 3 plus 5 is going to be inside of the parentheses. So that indicates that on that expression, the 3 plus 5 is going to be done first. Let's explore this with algebra tiles to see if they have the same result. So I know that inside of my parentheses, on the first expression, I'm going to have 2 plus 3, which is going to total 5 units. And then I'm going to add extra 5, which is going to give me a total of 10. Now, if I do it in another set of grouping, that means that the 2 is going to be outside, and the 3 plus 5 is going to be inside of the parentheses. Well, that means that inside of the parentheses, we have 8 units, and then I'm going to add 2 more. And that means that my total is going to be 10. That means that the associative property holds for addition. On the associative property of subtraction, we are going to explore at the following expression. We have inside the parentheses 5 minus 2, and then we subtract 1. We start with the parentheses because of my order of operation. 5 minus 2 is going to equal 3, and then I subtract 1. That means that my final result is going to be 2. Let's look at the other expression. We have 5 minus 2 minus 1, and the parenthesis now is going to be on the second part of the expression. So I have to start with 2 minus 1, which is equal to 1, and then I'm going to subtract 5 minus 1. This one, the result is going to be equal to 4. So I can see that the associative property does not work on subtraction. Now let's look at multiplication. And we have the following expression. Inside of a parenthesis, 10 times 3, and outside of it, times 2. The next expression is 10 outside multiplying the multiplication inside of the parentheses 3 times 2. So let's see if these different groupings are going to have the same result. If we have 3 groups of 10 inside of a parenthesis, that means that I'm going to have a total of 30. And if I have the times 2 outside, that just means that I have to times 30 2 times. And that means that I'm going to have a total of 60 units. Okay, so let's evaluate the next expression, which is 10 is outside, and we have 3 times 2 in the inside. If we have 2 groups of 3, that's going to be equal to 6. And if I add these 10 times, that means that I have a total of 60. So this means that the associative property also holds for multiplication. For the associative property on division, we're going to start with this expression. 4 divided by 2 in the parentheses, and then divided by 2 later. we start with the parentheses, and this is equal to 2. And then if I divide that by 2, that's going to be equal to 1. So that's my first result. Let's go to the next expression. Now we have the grouping change, and I'm gonna start the division on the far right. So I'm gonna keep the 4, and then 2 divided by 2 is gonna be equal to 1. Now I divide 4 by 1, and that's gonna give me a result of 4. So I can see that the associative property on division does not apply. Now we got to our final algebraic property, which is the distributive property of multiplication over addition. And what this is telling us is that if we have a multiplication over a addition inside of a parenthesis, then what can we do is we can multiply each term inside of the parenthesis by the number outside, and it's gonna give us the same result as if I was doing the order of operations. So let's explore this expression to see if it's true. I'm gonna start with order of operations right here. And I'm gonna evaluate the expression 6 plus 3 first. That's gonna be equal to 9, and then I'm gonna multiply times 5, which is gonna be equal to 45. So let's see now using the distributive property of multiplication over addition. I'm gonna have the same expression, but now I am going to start by multiplying 5 times 6 plus 5 times 3. Well, I know that 5 times 6 is going to equal 30, plus 5 times 3 is going to equal 15, and that means that my final result is going to be 45. So this shows you that we can use the distributive property of multiplication over addition, and it's gonna give us the same result. For our 7th grade section, our objective is going to be to apply and extend previous knowledge of operations in order for us to be able to solve problems using addition, subtraction, multiplication, and division of rational numbers. Specifically, we are going to be talking about integers. Remember that the integer grouping is going to be all the whole numbers and also its opposites, and that just means the negatives. Okay, so we're going to start with adding integers, and basically for adding integers we just have to remember 2 rules, and we're gonna be doing this by giving you guys examples. The first rule is that when you add numbers that have the same sign, the result is going to be the addition of those numbers, and the sign is going to be kept on the result. So let's just say that I have -3 plus -5. Well, I'm going to add them, and that's going to give me a total of 8. And then I have to keep the same sign, so that means that my result is going to be -8. Now that brings us to our second rule, which is that if I'm adding 2 numbers that have different signs, that means that I'm going to subtract them, and I'm gonna keep the sign of the largest number. See this example. I have +3 plus -5. So if I'm gonna subtract them, that's gonna give me a total of 2, and the highest number is actually that 5. So that means that my result is gonna be -2. Now we're gonna get to subtracting integers. And this is very important that you guys keep this as one rule for this operation. And the rule is that every time that you see the sign negative or the minus sign, you can think of it as adding the opposite. So for example, if I have $5 and I subtract 1, that's the same as saying that I have $5 and I'm adding a negative 1. Okay? So think of the minus sign as adding the opposite. Let's look at this example. We have positive 3 minus negative 5. Well, since we said that the minus means adding the opposite, I can rewrite this and say that this is positive 3 plus positive 5. And that will make it easier because now I can do the last two rules, which tell me that if they have the same sign, I just add them and keep the sign. So that means that my result is gonna be positive 8. This is an easy way for you guys to solve operations with integers, including subtraction. Now we get to the multiplication of integers. And for that, we are gonna be evaluating one operation, which is 5 times 4. And we are just gonna do it in 4 different ways in order for you guys to explore what are the 2 rules of multiplication of integers. So let's get started. If I multiply a positive 5 times a 4, I know that the result is gonna be 20. The complication comes when we have different signs involved. And that's what we're trying to explore in this exercise. So let's say that I have, this is the top one, 5 times negative 4. So since both of these numbers have different signs, my result is going to be negative 20. Let's say the next example is negative 5 times negative 4. We can see that both of them have the same sign, so my result is gonna be positive. Same with 5 times 4. Since both are positives, then the result is gonna be also positive. And the last one, negative 5 times 4, since both are different signs, that means that my result is going to be negative. So these give us the 2 rules of multiplication of integers that say if both numbers that you are multiplying have the same sign, they are gonna be positive. The result is gonna be positive. But if both numbers have different signs, then the result is going to be negative. For dividing integers, we actually have the same 2 rules. So now it's gonna be your turn to apply what you just learned on the last exercise. I'm gonna give you guys 20 seconds in order for you to be able to try this problem. And the problem says we have to divide 10 by 2. Let's see if you can get the correct signs. Okay, so let's see what the real answers are. On our first one, 10 divided by negative 2, our answer, since both have different signs, is gonna be negative 5. On the next one, negative 10 divided by negative 2, both have the same, so that means that our result is gonna be positive. 10 divided by 2, both are positive, so that means that the answer is also a positive. And negative 10 divided by positive 2, since both are different, that means that the result is going to be negative. So again, the rules for division of integers are the same as the rules for multiplication of integers. If they have the same sign, the result is positive. If they have different sign, the result is negative. We're going to explore some real-world problems that involve operations with integers. So we have this. A diver is swimming at 2 feet below sea level. He decides to descend 5 more feet. How many feet below sea level is he? For this, we're going to be solving this problem with a number line, and as well we're going to do it algebraically so we can see how it looks on both ways. So we have a diver that is at 2 feet below sea level. That means that on our number line below sea level, that means that it's negative. So we have our diver, and if we want to see it algebraically, we can say that we have a diver initially at -2, and then he wants to descend or subtract 5 more feet. But we said that every time that we have the sign of minus, we can just change it for a plus, and then we just have to change the 5 to its opposite. So we can rewrite it as -2 plus -5. Let's see in a number line. If we move 5 spaces to the bottom, that means that the diver is now going to be on -7 feet, or 7 feet below sea level, which is the same that we will get in our algebraic expression. Next problem says a hot air balloon descended 90 meters in 10 seconds. What was the balloon's average rate of descent in meters per second? So we have to realize that if we're talking about descent, we are talking about negative numbers. So we have -90 meters, and he descended in 10 seconds. So I'm going to put it right here. And what we want to know is what happens to this fraction when the seconds become only 1 second. And we have to remember that the relationship between these two denominators is that the 10 has to be divided by 10 in order to become 1. So that means that on top we are going to divide by 10 as well. If we divide 90 divided by 10, that'll be -9 meters. So we can say that the balloon average rate of descent was 9 meters per second. Now for our 8th grade section, we are going to be learning about simplifying expressions. And today's objective is going to be to use mathematical processes in order to acquire mathematical understanding. So before we start, we're gonna go through some key vocabulary. And the first word that I want you guys to remember is the word constant. When we talk about a constant on an expression, we are just talking about the number on that expression that does not change. This can be any number that doesn't have any type of variable. So let's see our example. It says 5x plus 2. Over here, the x is a variable that can be any number. The only number here that is not going to change is the number 2. And that is going to be our constant. The next word that we need to be acquainted with is the word coefficient. And the coefficient is going to be the number attached to the variable. the number that is gonna be repeated as many times as the variable's value is. In this case, the coefficient is gonna be the number 5 because it's beside the variable x. Now we can get started with some real world problems. Let's explore simplifying expressions with whole numbers. Let's read. Pedro buys an iPhone at a cell phone store. They charge him $40 activation fee. That's gonna be one of my constants. And he will pay $20 per month for his plan. Since I don't know how many months he's gonna have, I have to put a variable with the 20. And then it says plus $29 a month to pay for the phone. That will give me another $29 per month. That means that I have to add another variable. So when we are simplifying expressions, we just have to combine like terms. That means that if I have two coefficients, I can just add them together. So I can do 20 plus 29, and this expression will be simplified as $40 plus $49 per month. Now we're going to explore the same problem, but now we're going to add some integers. And in order for us to do that, I'm just going to add that Pedro is going to receive a discount of $30. So now we are having the same expression, which is $40 in constant and then $49 in variables, and we are gonna add these negative units of 30. So now in order for us to simplify, we just have to get all these positive tens and negative tens out of the way. So that means that if I have $40 and I get a discount of 30, I'm only gonna pay 10. So now my new expression after the simplification is going to be $10 in constant and $49 per month in variables. Now let's explore the same problem, but now instead of having a discount with a specific amount of dollars, we're gonna explore this with fractions. So let's say that Pedro received an offer on his activation fee and only pays half the price. So we have our expression $40 plus 49 per month. Now they're saying that this $40 is gonna be discounted by half. So that means that I just have to multiply the 40 times half. Now remember that in order to simplify the expression, I just have to multiply this, and it's gonna give me $20 plus $49 per month, and that is gonna be my new simplified expression. And now we got to the end of our lesson number 4. Thank you for watching, and remember that you can always visit HISD at Home for extra resources that you might need. If you want to see this video again, make sure that you follow me on Twitter or Instagram at Mr.Vivas, and I'm gonna be sharing all these videos so you can watch it on your own free time. Thank you so much, and I'll see you next time on Math at Home.